Question number 1 says, a herd of animals is growing, and the population after t years is the function p of t animals. And each of the formulas below represents one of the following. The original size of the herd, the average size of the herd in the past or the first 5 years, the net change in the size of the herd in the first 5 years, and the average rate of change of the size of the herd in the first 5 years. And we have to match these 5 formulas to these 4 situations. For the first formula, I matched it with option C, the net change in the size of the herd in the first 5 years, because seeing as P of T is a rate of change formula, when you take the derivative of it but also anti-derive it, it kind of cancels each other out, and then you are seeing the change from the interval 0 to 5, which would give you the overall change of the herd. So that would go with the net change of the size of the herd in the first 5 years. For number 2, we have the function of P with the input of 0. So I matched that to the original size of the herd, because on this, the interval would show at 0 there is no chance for the function to increase or decrease any, so it's going to be your original size that you're left with. For the third one, we have 1/5 times the integral 0 to 5, the derivative of the function p of t. And I match this to option D, the average rate of change of the size of the herd in the first 5 years, because similar to the first one, you're still going, these will essentially cancel out, and you're measuring on the interval 0 to 5, which is going to give you the net change. But then by adding the 1/5 out front, it gives you the average rate of change per year for 5 years. And then for the fourth one, we have 1/5 times the integral 0 to 5 of the formula P of T, and I match it with B, which is the average size of the herd in the first 5 years, because whenever you take the antiderivative of a rate of change formula, you'll be left with whatever that rate is measuring, which in this case would be the size of the herd, and then by having the 1/5 out front, it's going to give you the average throughout this 5 years. And then for the fifth formula, we're going with option D again, because it's similar to one of the example problems on the PCQs where you can't measure out each and every point. So by taking the formula at point, the end of the limit of 5, and then the beginning 0, it's going to give you the average rate, and then by dividing it through 5, it's going to be giving you the average throughout those 5 years. And next, we have to find the general antiderivatives and be sure to show evidence of the 5 steps of integration by substitution for questions C and D. For question C, I made u the 1 plus 5x cubed, and I chose this because this is in parentheses, and it's also all being raised to a power. And also I noticed that the x cubed will then change to x squared, which we can then get rid of. So when you take the derivative of it, you get 15x squared to the dx, and then I needed to change the 15 into a 10 to get this to cancel out or change into the du correctly. So I multiplied by 2/3 to both sides of this, and I got 2/3 du equals 10x squared dx. So then I substituted u in, so I had the integral of u to the 2/3 times 2/3 du, and then I took the 2/3 that was multiplied to the u outside the integral, so I could work with something more simple of the integral of u to the 2/3 du. And then when you antiderive u to the 2/3, you get 3/5 u raised to the 5/3, and then you still have to multiply that by the 2/3 outside the integral, and of course add the c. And when you do that, when you combine all these things together and put back the 1 plus 5x cubed in for u, you get 6/15 from multiplying these two fractions together, and then you substitute the u in, so 6/15, 1 plus 5x cubed raised to the 5/3 plus c. And for question D, we have the integral of sine of x and the square root of cosine of x. So I made u cosine of x because once again it's inside the square root, and I know that deriving cosine of x will get you sine. So we have the derivative being from cosine is negative sine x, and I then took the negative and moved it over to the other side, where negative du equals sine x dx. And from here, I substituted in u for cosine of x, and I also changed the square root to a 1/2 power. So I did u to the 1/2 power, and then I had the negative sign, and I kept that out, and also the sign is covered through the du. And then when you antiderive it, you get 2/3 u to the 3/2 plus c, and you have the negative sign from outside the integral, which stays on. And then when you resubstitute u, or cosine of x, in for u, you get negative 2/3 cosine of x raised to the 3/2 plus c. And that is your final answer.